we're going to be looking at the same diagram. I've blown it up a little bit and kind of written all the stuff we used for our last one on here, so it's a little less, hopefully more clear. I'm going to try to avoid using red as I write on the next one. So what we're going to do now is try to refocus and look for cosine of alpha plus beta in this diagram. Now, we're actually going to use, again, looking at some of the hints, and we're going to start with this angle right here, this triangle, which, because these lines are parallel, and that's my transversal, is alpha plus beta. So this is angle alpha plus beta. Then we're going to focus on this triangle here and write the cosine, because that's the relationship I'm worried about right now. The cosine of alpha plus beta is equal to dr, excuse me, that is not a d, dr over OR. And if you recall from our previous video, OR is 1. So, in other words, this line segment right here is cosine of alpha plus beta. So I'm going to go ahead and label it cosine alpha plus beta. And I'm going to highlight that, what we're looking for in green. This is the line segment I'm talking about. So this is a little trickier than our sine one, which is why, of course, we're doing it second. Where sine was very straightforward, what I was trying to do and find is sine of alpha plus beta was going to be these two line segments added together, and that's not as clear here. But what is going to happen is we're actually going to take this whole side, DC, and subtract, possibly, to help us find it. We'll see how it works out. Let's see what we can find. So we have some more pieces we're looking for here. And I'm going to go back to here. When I wrote alpha, angle alpha, I only wrote it for sine. I did not write down what the cosine was. So let's go ahead and do that for cosine here. The cosine of alpha, we'll use blue, cosine of this alpha right here, cosine alpha is equal to adjacent OA over hypotenuse, which is OB. Now, I know that OB, not O beta, OB is cosine beta. So that I can replace, I'm going to have cosine alpha equals OA over cosine beta. And so OA is equal to cosine alpha times cosine beta. So that means this side right here is cosine alpha times cosine beta. We can see that we're dealing with this line segment OA here at the bottom. All right, well, that's something. And over here, when I was dealing with this alpha, I did not use the sine. I only did the cosine. So let's go ahead and do the sine of that alpha and see what comes out of it. So sine alpha, using the other triangle, is going to equal opposite over hypotenuse. So RC over the hypotenuse of BR. And BR, we can see in our picture, is sine beta. So sine alpha equals RC over sine beta. And so sine alpha times sine beta equals RC. Or in other words, this section right here is sine alpha times sine beta. Remember, I'm looking for this green highlighted section. So when I focus on that green highlighted section, I can see it's DC, which is the same length as OA. So DC minus RC. So DC minus RC. So getting back to this, DC minus RC. And DC is cosine alpha minus cosine beta, excuse me, times cosine beta, not minus. And then I'm going to be subtracting RC, and RC is sine alpha times sine beta. So that is my relationship. So there we have it. We're going to go ahead and from this point come up with a couple of more things. So number 14 says we can use that relationship we just found to help us figure out this one. And so if you remember in question 12, we rewrote this as cosine, but we rewrote it so that it was cosine of alpha plus negative beta. So we're going to do the same thing here and use the relationship we just created. So we just said that it was going to be that cosine of alpha plus beta is cosine alpha times cosine beta, in this case negative beta, minus sine alpha times sine, in this case negative beta. And so we get cosine alpha times negative, this will be the same cosine of beta because it's even, minus sine alpha times negative sine beta because sine is an odd function. And so this becomes cosine alpha times cosine beta, nothing happened over here, plus negative negative sine alpha times sine beta. Okay, and so there we go. There we have it, cosine alpha times cosine beta plus sine alpha sine beta. So if you recall, with sine, we're adding in between our when it's addition. With sine of a difference, we subtract in between. With cosine of a sum, we're subtracting in between, and cosine of a difference, we're adding in between. And now we're going to get into what we call the double angle identities. So these are following in they're known as the double angle identities. They're just special cases of what we just did. So you can think of sine of 2 alpha as sine of alpha plus alpha. So what we're going to do is we're going to take our identity we found in our previous video and rewrite this. So we're going to have sine of alpha times cosine of alpha plus cosine alpha times sine alpha, because they're just the same angles. And what ends up happening is those two are the same. They're in different orders, but they're still the same as each other, cosine alpha. So we end up with 2 sine alphas times cosine beta. Excuse me, cosine alpha, no beta in this one. And so that is our answer. We're going to do the same thing here for cosine of 2 alpha, which can be rewritten as cosine alpha and plus alpha. And so we're going to get cosine alpha times cosine alpha minus sine alpha times sine alpha, which leads us to cosine squared alpha, because there are 2 of them, minus sine squared alpha. And there we have it. Those are our double angle identities. We use the double angle identities a lot. So when we're trying to find the sine of 120, if we can't remember it, that one's one we're supposed to know. But like if we were trying to find the sine of some angle, but doubling it is just often an easier way to play the game than the other ways. And these are 2 very important identities. And this is where they come from. So they're pretty straightforward to derive, and along with our sum and difference identities, which are what the other ones are called, we're ready to move forward and see what we can do with those. I hope this was helpful, and I'll see you soon.